Okay, so finding limits graphically and numerically. You're going to graphically and numerically do it. On Monday, all you were supposed to be doing was graphically. Limit is something that it approaches, not what it is. It's what it approaches. And in the wording, when you were doing your reading, it was the arrow says approaches. So as x approaches whatever value it is. So you just have to remember it's not asking you what it is. And that's one of the things I worry about. Because it's not asking me the value. This is red. The limit of f of x, and f of x is x cubed minus 1 over x minus 1. Okay? So it says the limit of f of x as x approaches 1. Approaches 1, not is 1. Because at 1, there's a hole. What's the value at 1?
3.
No. There's a hole. What's that mean? Put your chair down.
Does not include.
It does not exist. So the value at 1 does not exist. Correct? There's a hole. So that's not what it's asking you. This arrow says what? Approaches 1. So from the left and the right, you look at the graph. What are the y's approaching as x approaches 1? 3.
Oh.
Because at 1, it's not. It does not exist. And that was the whole point of the table. At 1, what's the value?
3.
No.
Does not exist.
Does not exist. Why is it does not exist?
Because it's an open.
Because it's an open circle.
What notes are
We're
we supposed to
open.
write for that, though?
Whatever you want to write.
That's
You
what
are
I
learning.
didn't
Okay,
understand
Maddie.
what notes-
Maddie, right now you're in a college class, so you need to learn to take notes. Listen, notes that are good for you. Okay? So I have up here, I've explained that this means approach here. So you need to write notes that you need for later. Okay? So at 3, this does not exist. D-N-E. What does D-N-E stand for?
Does not exist.
Does not exist. That is what the table is showing you. Look what happens. I go 0.75, 0.9, 0.99, 0.9999. Is that getting closer and closer to 1 on the left? Yes. Now on the right, 1.001, 1.01, 1.1, is that getting further away? Or if I go from the right, does it get closer to 1? Look at the table. What are both the values approaching? Right here and right here. What are both values approaching? 3. Get it?
Yeah.
A limit is not what it is. It's what?
What it's approaching.
What it's approaching. So do you need to have that in your notes? A limit is not what it is. It is what?
Approach.
What it is approaching. Now, we can get lucky and we could plug in 1 and get a value. That'd be great. But it doesn't always happen. Today and tomorrow, or today we're doing graphically and numerically using a table, not analytically. Analytically is we're using the function, the math, okay? So we're using a picture and a table today. We will learn algebraically because this is not efficient. What we're doing, what you did Friday, what you're doing today is not efficient. This is like bare bones concept. You have to be efficient at it, and we want stuff that works. Okay? So, if f of x becomes arbitrarily close to a single number L as x approaches C, okay, from either side, the limit of f of x as x approaches C is L. This is what this statement said. That's directly from your book. The limit of f of x as x approaches C equals L. Capital L stands for what? What do you guess? Limit. Okay? Limits. We've done asymptotes. Yes? It approaches. Okay? But then they shoot off, and we have a rule for that here. You'll learn in a minute. But that's kind of the same type of thing. So we have decisions to make that we need to do. So we can have a picture, and everything you had yesterday or Friday was pictures, correct? Mm-hmm. Okay, that's not going to happen today. Today you have to make a table. Okay, so you need to pull out your calculator. And you need to put the function into your calculator. Where do we put functions in our calculator? Y equals. Every single time, right? So down here it says the limit as x approaches 2 of x squared minus 3x plus 2 and x minus 2. Look at their numbers on their chart. What do you notice about them from the left? They get closer and closer to what?
2.
2. Now could I add another 9 and another 9 and another 9 and 28 nines? Yes. Am I still 2 though? Nope. What about if I come from the right? I would just add more and more zeros, yes? To get closer and closer to 2 from the right? Does everyone get what I'm saying from the left and from the right? Numbers on the right are bigger than the number, correct? Numbers on the left are smaller. So does everyone have that in their calculator? Not the limit, just the equation. Remember, what do you need to put around your numerator and denominator? Parentheses. And we have made tables before in our calculator, yes?
Yes.
Now, they have given us the numbers, so they're nice. So since I already know the numbers that I need, where do I go to make it so I can put my own numbers in?
Go to second table set? No, second table.
No, second table set. Yep, second table set. And what do you need to... Anything to do with a table or a graph is right under the graph. You're hitting table set.
Where are you finding set?
Table set right under the... Okay, listen. Anything, again, I'm going to say it. I'm going to say it every time. Anything that does with a table or a graph, where are those keys?
Top.
Right under the what? The screen. Okay, did everyone find table set?
Yes.
So table set, I think it's just TABSET. Yes? Okay. What do we need to change? I want to be able to put my own information in there.
Independent.
Independent to what? Ask. You want your independent to ask.
What does that mean or do?
It's going to let you put your own in.
Enter.
Okay, enter. Okay, now you got to go to your what?
No, it's not.
It didn't do anything because you haven't done what? What do you need to go to?
Graph.
No, what did you just change?
Oh, we have to put it in.
We need to do table start, right?
Or just table. Where's table at?
Second. It says table 1.
Second graph. Okay. So now, does it completely blank on your table?
Yes.
So you need to plug in your what?
X.
Plug in your X's, all of them. Are they giving you answers?
Yes.
Yes. Put them on your paper.
So I'm confused as to like the ask thing. How do we know that we use that on the dependent or the deep?
Isn't X independent?
2 says error.
Independent, not
Oh, yeah,
dependent. Because that's what X's are. X's are independent variables.
Okay, so
If you knew your Y's, you could plug in your Y's and get out your X's if you change your dependent.
2 says error.
Yep, it does. Why? Look at the equation.
because it doesn't exist.
What?
It's an open circle, so it doesn't exist.
Right. Why is an open circle?
Because
Because it's, yeah.
the limit.
Or no.
No.
it approaches.
What is wrong with 2, guys? No. What is wrong with 2? Look at the
You
problem.
can't get a 0 in the denominator.
You can't have a 0 denominator. So does this problem exist at 2? No, it's a vertical asymptote on the graph. Okay? So what number are these approaching? What is 1.99? What is it?
99.
1.99. What is your X?
0.99.
Okay. I thought you were telling me like what I just did. Okay, 0.99. What's 1.99?
0.999.
3. Okay, from the right, what is 2.001?
1.001.
1.001. What's the next one? 1.25?
2.5. No, wait. Oh, wait, correct.
2.01 shouldn't be 0.25.
Yeah, I messed it up. I'm sorry.
Okay, what is 2.
No, I did too.
What is 2.01?
1.01.
Okay, so what number are these values approaching from the left?
1.
1. What are they approaching from the right?
1.
1. So the limit as x approaches 2, because at 2 it's undefined, yes?
Mm-hmm.
Okay, so the limit of x squared minus 3x plus 2 over x minus 2 as x approaches 2 is what?
Is 1.
1.
Wait, say that again. Sorry.
Look at your graph, your
Yeah.
table. What are the numbers approaching?
Well, they go up by 1. And
No,
They go down by
no. What number is this approaching? What is it getting closer to?
Oh.
1.
What number is this approaching?
1.
1. So the limit is what?
1.
1.
Why when I punch in the table, like the numbers, some of them like disappeared.
Like on the bottom, like the
Yeah.
last row, it's because there's not enough room on it.
But shouldn't you be able to like go down?
Well, press the arrow. It doesn't go down.
No, as you push enter, it should keep going down.
No, mine doesn't even do that either. It just
So, like-
replaces the bottom number.
Yeah. So like.
Well, you can only go to 10 or 9 or whatever's on there.
Yeah.
Yeah, that's it.
So then what do you?
You write them down and look at your paper.
Mhm.
On your paper, you should have this table. Not right now, but on
We
your,
went to
well, right now, but I'm not going to wait for
We
you to
went
copy it
second
now.
tab set after we put in the Y, right?
Yep. Y equals
Then we go to
table set, independent to ask, and then you went to where?
then table.
Table. Your assignment is going to be making what?
Graph.
So we're doing
Tables.
this.
Tables.
Yes.
So then you. Okay, never mind. That's a stupid question.
No. What's your question?
I was just like gonna ask you like, how do you want us to make our tables on the assignment? Like just like that?
Mm-hmm.
Okay.
If
So
you
we
want to
can-
make them vertical,
Okay.
make them vertical. I don't care.
I just didn't.
Yeah, I would probably make them vertical because I don't want to do horizontal. Yes.
Are we gonna go over like the graphing part of it?
You just hit graph.
No, but like what we did yesterday.
You just hit graph and look at it.
So what were we doing? Was it right?
No. You have to do approaches. So when I went here and I looked at this, you guys were saying, oh, what is it?
We said 3.
That you said 3, and it's right that it's 3, but it's because here it's approaching 3 and here it's approaching 3. Not because at 1 it's 3, because it's not anything at 1, is it? That's
But we still found the answer.
yes.
Okay.
But they don't exist sometimes, so you can't do it that way. What you were doing was not a right method. You were getting the right answer because it happened to be that way. You'll see what I mean in a second. Okay, so we have a square root function, yes? Okay, so I want the limit of x divided by the square root of x plus 1 minus 1 as x approaches what?
0.
0. Here's my graph. I can see it good. When I go from the left and from the right, I'm going here to here. What is the y approaching as x's are both approaching 0? From the left and from the right. What is the y approaching?
0.
No.
2.
2. Y's are up and down. X's are approaching 0. What is the y approaching? 2. Now, does this function exist at 2?
No.
Why not?
Open circle.
Yes, but on the equation, what would 2 do to this?
It would make it.
If I had 2 plus 1,
You would,
oh, 0. Sorry, 0, not 2. So if I plug in 0,
why is it 0?
because x is 0.
Okay.
If I plug in 0, it'd be 0 plus 1, which would be 1. The square root of 1 is
1.
1, and 1 minus 1 is
0.
0.
Sorry.
It can't be 0, can it?
No.
No. Okay, so looking at that graph, that is what you should have done on Friday. From the left and from the right. As the x's come in, like this, where is the y approaching?
Yeah.
Where is it approaching?
There?
Where? Say it.
0.
No. X is approaching 0. X is approaching 0. What is y approaching? 2. You have to keep straight what's happening. As X's are approaching, what is your Y doing? Okay? So, now, today you're going to make a table. So, how do you make a table?
Y equals.
Okay, you're going to do Y equals. You're going to put it in there. You're going to put parentheses around the denominator, yes? And you're going to put all that in. What happens right at 0? Does not exist. Why? Why does it not exist at 0?
Because, yeah, you can't have 0 in...
0 makes the denominator 0, so you can't have it. So, there is my table. What is my limit approaching? 2. Do you see that on the table? Looking at these numbers right here, what are they getting closer and closer to on the left?
2.
2. What are they getting closer and closer to on the right?
2.
2. So what is the limit?
2.
2.
So my calculator is like rounding them up.
No, it doesn't matter. It's going to come out to be the same.
It doesn't matter. Because,
It's
like,
going to still be approximately 2, correct?
Okay, because I just put negative 0.01 and then my FX was 1.995.
It's fine.
Okay.
This is a computer, not a calculator. Does everyone know how to do this? So we don't waste our time with you just plugging them in.
Is there supposed to be parentheses after square root?
Yes.
So square root parentheses x plus 1. Oh, well. Yeah?
You should have to have x plus 1 in the square root with a parentheses.
Yeah, I don't know why my I can't delete it.
You should have parenthesis, square root, and then it should pop up a parenthesis. You put x plus 1 and that parenthesis minus 1 and then 2 parentheses. No, 1 parenthesis.
My table's already filled out, and I don't know how to get it off there. This is
No,
like-
you go back up and re-put them in over it. That's all you do.
Second
Oh, okay.
window. Table.
You don't have to hit table set ask every time because you've already done it.
Oh,
So then I hit second.
I think I reset my Y and so
Mine
now
says
it's not
error
giving me
syntax.
answers.
How did you reset your, what do you mean reset your Y?
Because when I get back.
You deleted it.
Yeah.
That's it.
So,
It's don't worry about it.
okay.
Shut that off.
But it'll work when I go
Yes.
to plug it in.
Yeah, we'll do another one.
Mine says error syntax.
Then you put in probably a negative instead of a minus. Or you didn't put parentheses in the right place.
How do I go back?
When you put this in your calculator, it should be x divided by parenthesis, square root,
I put a
parenthesis,
on
x plus 1, parenthesis, minus 1, parenthesis.
that. Put a parentheses.
After we've typed it in, what do we go to again?
Table.
Does it matter if there's a parentheses around the x?
No. If you have 2 of them, you have to have 2 of them.
I do.
Mine do not show those numbers.
Are they close to those numbers?
No.
Do they round up to like?
Did you put it in right? Do you have x divided by parentheses, square root? Did you end your square root?
X divided by, I think so.
So, like, if they're close, they're...
Well, they're still. Are they still going to 2 on your table?
Yeah.
Okay. I don't care what they are as long as they're going to 2. Got it?
What?
Maddie, did you find your mistake?
Okay. So I don't have to go to table set.
No, not unless you change it back.
Second graph, go.
And then you type in your numbers.
So I have to delete the other ones.
No, just go over them and type over them. You don't have to delete them.
Oh,
Okay, next.
we already moving on.
Okay,
Error.
find the limit of f of x. Here's your graph. Approaches 2. It's the limit.
What it,
2.
Mm-hmm. Why isn't it 0?
Because 0 is an open.
No. At 2, it's 0. Why isn't it 0? Please tell me the
That's
right
not
thing.
where it's approaching.
It's not where it's approaching. It is approaching 1. I think you said 2, but it should be 1. It's approaching 1, yes?
Yeah.
At 2, it is what? 0. But what is it approaching from both sides? Do you see that?
So that would be 1.
That would be 1. So your table would be something like 0.999 and then 0 and then 1.001. Okay? And then it'd be some numbers over here and some numbers over here. Make sense?
Yeah, well, like,
So what is it approaching here and what is it approaching here?
0.
No,
one.
1.
I just,
0.99 and 1.001. Shh. Stop and listen. What is 1.99 approximately?
1.
1. What is
I was
1.001?
looking at the 0.
I know. Let me finish, please. You don't care what it is at 2. I do not care. That's what we got to get over. I'm asking what is it approaching, not what it is. If I wanted to know what it was, I would write this. F of 2, wouldn't I?
Yeah,
And what is f of 2?
that would be
0.
0.
Everyone see the difference? Okay. Gentry, does that make sense now?
Yeah, I was looking at the 0, so I said.
Right, I know, but I wanted to finish my statement. Yes.
I'm just really confused because with the example it says find the limit of fx as x approaches 2.
Yes.
So wouldn't it like, but you're saying that it's not approaching 2, it's approaching 1 instead.
No. Up here, this is 2. This is what's the number?
Oh.
2.001. And this is 1.99. These are my x's, right? And these are my y's.
I was just really
Yeah.
confused because when you circled like the 2 down there, you said that it's not approaching around. So that's-
It's not, yeah, it's not approaching 0.
And yeah, I know
Okay.
that. I was just really confused because you're like, you said it's not approaching this 2 because it's 0, and so I was like, okay, well then why does the directions say x approaches 2? So
No,
that's what I
okay.
was just really confused.
Yeah, so the question is, what are the y's as x approaches 2?
Okay.
So the y's are 1.
Okay.
Yes?
Yeah.
What is, now down here, what is it asking?
What is it at 2?
What is it at 2? Are those two different statements?
Yeah.
Yes. So the limit so this one would say the limit as x approaches 2. And that would be this equation, yes?
Yeah.
So, but the limit of f of x is 1. But at 2, it is what? 0.
So how would we, like, in our graph, because we'll probably have, like, an equation of that or something on the assignment, how would we put that in, like, as y equals, like, to find...
Oh, a piecewise function?
Yeah, like, how do we do that?
I don't think they're going to get a piecewise function. I would assume they would give you a picture.
Okay,
I don't think you have to graph any of those.
okay.
In every, yeah.
So then how do you want us to, like, put that on the table then?
This would not be a table.
You don't do
Oh,
it.
okay.
This would not be a table. Okay, so we have some things when the limit does not exist. Anybody seen Mean Girls before?
Yep.
The only thing she can remember out of calculus is the limit does not exist. Okay, so you get to say that. Okay, the limit does not exist if it approaches two different numbers from the left and the right. Okay, paraphrase that. Limit does not exist if from the left and from the right they approach two different numbers. Doesn't exist. Okay? The limit does not exist if it increases or decreases without bound. That would mean at an asymptote. Yes? So, oops. That would be something like this, and it would go like this. Yeah? And like that. Okay? It doesn't exist. Can we get to infinity or negative infinity? No. Doesn't exist. The limit does not exist if it oscillates between two different values. Okay? And it's something nice and fun, like it's all going like this, and it's great, and then it goes.
Oh.
Okay. So, and I'm going to show you examples of each of these. But when I ask you, the answer is DNE, standing for what?
Does not exist.
And then you have to give me for one of these reasons. You cannot just tell me DNE. Got it?
So increases or decreases without bound is if there's an asymptote.
I'll show you. We'll have pictures.
Oscillates? Oh, have you talked about that? Or
No, I will have pictures of all three.
Okay.
We will do all three. Okay? It's 3 sides and then we're done today. Okay, so does the limit of the absolute value of x over x as x approaches 0 exist? Well, from the left, as x approaches 0, what is y approaching?
Um,
-1?
Yes.
Yep. And from the right, as x approaches 0, what is the y approaching?
1.
1. Is that two different values?
Yes.
Yes. So no, it does not exist because it approaches two different values. Got it?
that's
So
what
you would
offset
write
is.
D, N, E approaches two different values, or approaches -1 and 1, or approaches -1 from the left and 1 from the right. Whatever you say in some terms has to say approaches two different values. Does that make sense?
This is the first one, the first, like,
It's
Yeah,
on
yeah, yeah.
page 51 on our chapter things, the words, so you can go back and rewrite it when it does not exist.
Okay. So now, other options. What if I ask you the limit as x approached 1? Same graph. What would you tell me? 1 from the left, 1 from the right.
It'd be the same thing.
No.
no, it would be.
It would be what? As
It does
x.
exist.
It does exist, and what is it? 1.
Wait. So you're
Okay, same graph. You can't just say, I saw a graph like that, it means it doesn't exist. Can't. You got to do it. You got to look at the observation. So, from the left and from the right, here's 1. Yes?
yes.
Okay. From the left, as x approaches 1, what is the y? 1. From the right, as x approaches 1, what is the y?
1.
1. So what is the limit here?
1.
1. See the difference?
Yeah.
Okay, x approaches -1. So -1's right here, yes?
Yes.
Okay, from the left, what is the y approaching? -1. From the right, what is the y approaching? -1. So the answer is -1. So just because it does not exist at one place, does that mean it does not exist at every place? No. So just make sure. Yes.
Okay, so -1 or 1, couldn't you change the dots at like -1? Like for like x approaches 1 equals 1. Couldn't we change that to -1? Because there's two different values there.
No. If it approaches two different values at 0, it doesn't exist.
Now you're changing it.
I just made a different problem. If I had this right here was 1, the answer would be 1. If it was -1, the answer would be -1. Okay? So that's two different values. But I wanted you to show that you can't just see a graph that's discontinuous and say, oh, the limit doesn't exist. You have to look at the number that they're talking about.
Okay.
Yes. Okay. So now,
Oh gosh.
at 0, this is 0, yes?
Whoa. 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 Whoa.
Okay. So here is 0. Yes?
Where?
Should be writing on mine. It's writing on mine.
Can you not yawn? You make me yawn.
What is this?
You can have it though.
Okay. Now can I write on there?
No.
Okay, so here's 0, yes?
Yes.
So as x approaches 0 from the left, what are the y's doing?
Going.
Where are they going? They're going to positive infinity, yes?
Oh, yeah.
Okay, as x approaches 0 from the right, what are the y's doing? Positive infinity. So are they increasing without bound?
Yes.
Yes.
Which
So-
they can't do.
Which they can't do because that was the second rule, yes? So it doesn't exist because they are increasing without bound. Without bound means infinity, yes? Now, what if I changed again, instead of approaching 0, what if I said approaches 2?
Then it's still, yeah.
No, be careful.
Without the asymptotes?
If I'm approaching 2, so that means I go here and here.
They're approaching.
They're approaching
Zero.
something. No, they're approaching this right here. What is it?
2.
Probably like 0.25 or something. But you see, if it approaches 2, is there going to be a limit?
Yes.
Yes. But if I'm approaching 0, is there going to be a limit? No,
So
doesn't
what if
exist.
it was 0.25 on the X line?
If it was 0.25 on the X,
Yeah, it would.
that would be the same.
Does not exist.
Yeah. Well, it probably would exist, but you wouldn't see it on
Not the
here.
graph.
Yeah, it's because it's only an asymptote at 0. So at 0.25, I'm sure the limit would exist. That would be something you would need to use a table for. Okay. Tables are very inefficient, but for something like this graph with 0.25, would be the way you would have to go? Yes. And we will learn mathematically some things that can help us with that too. Okay, the last one is oscillate. Now, do you see what I mean by oscillate?
Yeah.
If I zoomed into that, it would be like going back and forth a lot. So the limit of the sine of 1 over x as x approaches 0. There's a table right there to show you. Okay? What's happening to those numbers as it's approaching 0? 1, negative 1, 1, negative 1, 1, negative 1, 1, negative 1. Is it oscillating between 2 values? Yes. Okay. So since it's oscillating between 2 values, then the limit does not exist. Now, if I asked for a limit, clear out here. What about at negative 1? If I asked for x approaches negative 1, would there be a limit?
If it was what?
Right here at negative 1.
Yes.
Yes, it would be whatever that is, right? Because is it oscillating right here?
No.
No, it's not oscillating there, so it's all good. But at 0, is this thing going nuts?
So if it oscillates between 2 numbers.
Well, if it oscillates between 2 numbers as what you're approaching, it wouldn't exist. Like this, if I wanted to approach negative 1, it'd be all good. But since I'm approaching 0 and that thing's going nuts, it's kind of the same as approaching 2 different values, yes? Kind of? So, now be careful though when you're here. Sometimes you'll have graphs that go like down to negative infinity. They go to negative infinity. And somebody will say it doesn't exist because it approaches 2 different values. Is that true? Is infinity a value? No. So in this case, it would be does not exist because it approaches negative and positive infinity. Does that make sense?
Wait, so you're saying
If one went up, like if this one went down and this one went up, I have people say it approaches 2 different values. Infinity's not a value. So the correct reason why it doesn't exist is it increases or decreases without bound. Okay? Now, you will also find some textbooks that people will say, oh, it goes to infinity. That's not a limit. That's not a value. Okay? So today you're making tables. Okay? There may be some graphs you look at it, but the majority are making tables and just write them. I don't care if you do them horizontal or vertical. Just make your table. Got it? Okay. So your assignment is just odds, right?